Yeah, now we can see.
I show you now my program.
Cool.
This
Okay.
is my program.
Yeah,
You
we
can
see
download
Kaushika,
it
your screen.
on
Download?
the research gate.
Right?
Can you see?
Okay.
Yes.
Yeah,
That's pretty
you can
cool.
see now.
Calculation of
Propagation speed.
propagation speeds of acoustic waves.
Yes.
Is it
Right.
this is program I have written, I have created.
Wow. That's really
Wow,
cool
that's
looking.
great.
That
Looks
really
great.
good.
This is
Looks
my
very interesting.
institution, International Institute of Zakharenko Waves.
I've been to
I
your
created. I work already for this institution already for several decades, and you can see a lot of here data.
Yeah.
Above, there are parameters for a vacuum, and
Right.
you know that acoustic waves can't propagate in a vacuum, but they can be coupled if you treat, for example, piezoelectrics or piezomagnetics or piezoelectromagnetics. I study these acoustic waves, piezoelectromagnetic, for example, waves, can be coupled with both the electrical and magnetic potentials. And therefore, it is useful to put here in the upper part of this main window the parameter for a vacuum.
Right.
You can see maybe it is new for you, gravity constant, torsionic constant, isn't?
Yeah, that's new to me.
Probably you know electromagnetic constant, but new constants are gravitotorsionic,
Yeah.
torsion-magnetic, gravitomagnetic, torsion-electric, and therefore new speeds. It
Wow.
is concerned with new speeds that can be supported their propagation by a vacuum.
Right.
These speeds, these new fast speeds, are 13 orders faster than the speed
Hello,
of
I
light.
cannot hear now.
13 orders.
13 orders, yes.
Right. Cool.
Probably, if you will read the upcoming issue of the Canadian Journal of
Yes.
Power and Applied Sciences, you will see two experimental papers by one guy, researcher from Australia,
Okay.
about his research, experimental research concerning new radiation, new physics. It's concerned with the torsionic part, and it is coupled with this new type of connection. Namely, it is I'm interested in the development of the new type of connection called the instant interplanetary communication.
Right.
Because you see that 13 orders faster is already enough to communicate in an instant way, not only between planets, but also between star systems in the same galaxy, or even between neighbor galaxies, or even galaxies distant very far from each other, because this speed 10 power 21 meter per second, it's already a speed that is enough to propagate for a signal within the whole universe, within 1 second only, even less, several orders less, several probably millisecond time will be spent by a signal to cross our universe. Even though I have calculated it several years ago, and you know, some works by famous Soviet and Russian researcher. His name is Kozyrev.
Yes, I have heard of him. I read him in your research, but I'd heard of him before. And I think you referenced David Wilcox as well. You may have said something about him before. Is that correct?
Yes, it's an online paper, isn't the secret? The breakthrough by Kozyrev, isn't? Oh, okay, I can continue about my results.
Go ahead.
I don't want to say about Kozyrev results. His results are famous. He has developed hardware. This is not optical hardware to see stars at real time, because if you use optical tools, you can see star radiation from light from star distant, for example, 100 light years from us. It is not a real position, because this star has 100 years to move on our sky, because galaxies are moving faster than stars, and stars are moving faster than planets around. You know?
Yes.
And therefore, Kozyrev has developed experimental tools to see right position, not optical tool. And I think that he has detected signals, namely these signals 13 orders faster than the speed of light.
Right.
Namely these signals he deals, because nothing is known. Only these two fast signals can be.
Is there a gravitational signal? 13 orders faster than light. Is that gravitational?
The light speed, yeah. 13 orders faster than the light speed.
Oh, so that's the gravitational speed.
And yes, it's enough to see stars at the right position. Not because you know, you can understand that optical tools can't demonstrate right position. Only within our solar system we can see the right position of planets around the Earth.
Yeah.
So is the acoustic, Aleksey, is the acoustic wave converting to gravitational field, and then?
I study the acoustic waves coupled with all potentials. Namely,
is that phonon? Is that phonons?
Sorry?
Is it phonon?
I study the acoustic waves, but phonons are the elementary particles of the crystal lattice.
Yes.
But I study not quantum things. I study bulk materials. Bulk materials. But you know that we use the electric constant and the magnetic constant and these two constants can be represented through Planck time, Planck length. This is already quantum thing. But I study bulk materials, and acoustic waves are propagated. In general, I study surface waves.
Surface, oh, okay.
Surface waves, because these waves, acoustic waves, are very sensitive. You see that clean surface is very sensitive, and anything from the air, any molecules, atoms can stick, can be catched by the surface, because surface is very active. It is not compensated by atoms, and it is like to captivate many atoms, select some atoms to captivate, and it is good for biosensors, chemisensors, for instance. But I study namely the acoustic waves. I'm looking for the propagation waves for surface waves.
So it couples. So the acoustic wave couple with the surface waves?
Surface acoustic waves, there are many acoustic waves, bulk acoustic waves, surface acoustic waves, leaky surface acoustic waves, and I study only a part of each, namely surface acoustic waves, because I can't touch. It's very large arena, research arena, and I do only particular thing, namely surface acoustic waves at the moment.
But it couples with the gravitational or
yes,
the
acoustic surface acoustic waves are very sensitive, and the propagation of surface acoustic waves in my study are coupled with 4 potentials. If you know that Einstein has developed right to develop to the end of his life to connect all 4 fields, namely electric field, magnetic field, gravitational field, and torsional field. You know that Cartan, who worked with Einstein, has introduced this 4 field, and he has called it torsional wave. He worked with Einstein. It was before the creation of the quantum physics, and you know that Einstein was not agree with some, maybe any position of the quantum physics.
Oh, yeah.
His very famous phrase is God does not play dice.
Exactly. Yeah, I mean, there is a disconnect between quantum physics and relativistic physics. There is a disconnect. They don't agree. They don't agree with each other, you know?
Yes, because these surface acoustic waves are coupled with 4 potentials, these 4 known potentials or fields. Anyway, Einstein and many researchers are dealing with fields, but not potential. They prefer to deal with fields, but not potential.
Oh yeah, now
potentials, corresponding potentials, because you know that the electric field can be expressed using the electrical potential. It is usual thing, and in general, in the some approximation, and you see that acoustic waves are slow waves. They propagate in solids with the speeds 5 orders smaller than the speed of light. And
but how does it travel? How does it transmit through the vacuum?
Acoustics waves are coupled with the electrical and magnetical potentials, and this through this potential, through these fields, they interact with a vacuum, the corresponding vacuum parameters. Because
is it like charge couple, like charge couple coupling?
Yes, in the theory, it is very in the modeling of the acoustic waves. It is possible. It is not natural to.
You dropped out.
Yeah, something happened. Yeah, now you can see.
Okay.
Oh,
and
cool.
my browser, and I show now the Canadian Journal of Plant and Applied Sciences, and
right.
It is still the second issue. There is not the new 3 issue, and in the 3rd issue, in the October issue, you can read 2 papers by Zamsha, who experimentally works with this new physics concerning fast communication, fast interplanetary communication. He creates some already for many years some devices, and these devices are very expensive. You can read these 2 papers, and my site
I can
is
see
here.
Christopher's
This
abstract.
is my site. This is my site. I created my new site.
Oh yeah, I like this site. This is a great site, by the way. Although, did you do some new work on it recently?
Something
probably Steve knows this site, and of isn't of all of you
cannot see the screen.
This site, I mean, can you see?
Yeah, IIZWs.
Yes, and this is the planet Mars. This is the planet Earth, and you see the sun. I have simply designed something. This manifests the interplanetary communication I would like to develop. And this is
so if the aliens are there, they can communicate. If aliens are there, they can communicate with us.
Well,
hello.
Can you hear it?
What's going on? Something is happening. Is the aliens communicating now?
It's Dr. Stephen Greer trying to talk to us from the other side of the universe.
From the infinity.
I think, are those the waves that he's talking about? How do you say them?
Acoustic waves?
No, I think it's Aleksey's brand of waves.
This is my internet website already. This is not a computer program.
Right?
Last time I presented my computer program, you can download on this site. You can see and download my publication, for example.
Yeah. Right.
I have combined here all my publications.
It's a great site. I like the way it looks.
Can hear some sounds.
Main page. This is my curriculum vitae.
Cool.
My identifications. Last
Oh yeah.
2 years ago, I was awarded by the Web of Science Research ID because I have about 20 papers published in journals. I indexed by the Web of Science, and they grant the ID. I don't know how many papers should one researcher have to be granted by this ID. I have 20
Okay.
papers. And
Great. And were you given that in 2019 then, or is that just incidental? Probably.
Oh, we can ask, where is Dr. Khan? Where does he live?
Professor
Zahir Khan?
Zahir Khan?
something looks like there is communication from different planets.
Oh, this is communication we are
Some,
hearing.
some noise.
Yeah.
Oh, we are hearing this communication, interplanetary communication. Is this noise?
Yeah.
Oh.
From which,
is it like gravitational waves? Is it connected with gravitational waves also?
no, they're called Zakharenko waves.
Oh,
they probably are.
Yes.
I don't know.
I have discovered by about 200 new waves, and included these two new fast waves. This is my discovery, and by about 200 waves, acoustic waves. And these two new fast waves are not acoustic waves. They are because in a vacuum, any acoustic waves can't propagate.
yes, that's what
It
I
is
thought.
slow waves, acoustic
So it
waves.
is connected magnetic coupling. Is it how it? Is it like magnetic coupling?
Yes, acoustic waves can propagate in, for example, solids, and their propagation in solids
Yes.
can be coupled with the electrical and magnetic potential for the piezoelectromagnetic waves. And these two potentials are for solids, for the solid in which these acoustic waves propagate, and through this electric subsystem and magnetic subsystems, there is also the coupling with a vacuum. If you want to include this coupling.
Are you saying that the acoustical waves travel as though they are traveling through a solid, but through the vacuum structure?
Through the vacuum are traveling only the electrical subsystem of a vacuum and the magnetic subsystem of a vacuum, which is coupled with the traveling acoustical waves in the solid. It is possible to say in this way. Is it understandable?
Yeah. So Christopher, I think our circuitry may be the key then. We are putting a new circuitry, Aleksey. We are publishing that hopefully next month. I think they will publish
Hopefully.
We are the final stages. And then this circuitry will say that it can actually, any phonons and photons, it can, dissociate into separate magnetic tensor and electric tensor. And then I think it's possible that this acoustic wave is doing the same thing. It is dissociating into electric tensor and magnetic tensor, and then it's able to travel separately through vacuum and then recombine as acoustic waves, probably. Is that possible?
Yes, the electromagnetic waves traveling in vacuum are known as the light.
Yes.
And in a solid or in the air, they are called the electromagnetic waves.
Yes.
They propagate with a speed, with speeds close to the speed of the electromagnetic waves in a vacuum, to the speed of light. In general, it is slightly slower slightly for the electromagnetic waves, but the electric and magnetic potentials are not too strong to speed up the acoustical waves, because the acoustical waves are slow waves. They propagate with speeds 5 orders smaller than the speed of light.
Oh, okay. That's almost the speed of sound, right?
And when the acoustical waves are coupled with both the electrical and magnetic potentials, the speed is slightly accelerated, only slightly, several percent. But it is some engineering problem to find materials, solids with high coupling constants, to have high coupling between or among these three subsystems. In general, piezoelectrics are known. There are many papers concerning piezoelectrics, and in this material there are only two.
Like supersonic speed.
Sorry.
Supersonic, like above the sound speed of sound.
Yes, speed of sound. It is several thousand meters per second in general in solids.
Yes.
Only diamond can support propagation of acoustical waves 1 order faster than 1,000 meters per second.
Yeah, actually, sound travels faster in solids.
Yeah.
The light travels slower. It's just the opposite. Yeah.
Yes, the electromagnetic waves propagate in solids slightly slower than
but the sound acoustic waves can travel faster. Yeah.
Yes, when the acoustical waves are coupled with the electrical and magnetic potentials, they propagate slightly, several percent only, faster than without coupling.
Yeah, coupling is important, yes. Like it has to vibrate. It has to cause vibrations in the lattice, the crystal lattice. So if it vibrates, then through vibrational transfer, it can transfer the information, the waves. So it has to couple, yeah. So the coupling, like you said, the coupling constant is probably the key.
So that's interesting. So are the waves, there's sound waves moving through a solid that's piezoelectric, and then does that create these faster sound waves, or is that something like that? Or am I way off? be
I
way.
think he's again dropped off. Alexei, are you still there? He's dropped off.
Sound-wise, yeah. I can still see.
He says Toshiba is heating up. It has an overheating problem, Toshiba.
Right. He's not saying that in the chat, though. No. I can
Is he in the chat?
There was definitely some sound coming through his mic there for a second, though. Are you still there? Oh, I should address that to him. It's about this time of night my brain starts to slow down incredibly.
Have another beer.
Now you are past.
Gosh.
It's almost 1 o'clock, right, or something? Is it like?
I actually think the beer is making it worse.
11 o'clock, 11 or something.
Yes,
right?
that's right. It's 11, but like once 12 o'clock comes, then I really start to slow down.
Then it all starts. Your brain wants to take the rest.
That's it. And the beer is not helping. But actually, this is really interesting that you're finding similarities between Aleksey's work there and your own the PDP.
Yeah, I think there may be some connection. Eventually, we'll be able to.
You were
because I think our thing also coupling is important. The coupling becomes important.
Sure.
Like his thing.
Wait a second, Raja. Can I talk? You were talking about photons and photons. Remember?
Yeah, I can only barely hear. I think there is some interference.
Elementary photons are elementary particles of electromagnetic waves. Photons are particles, but electromagnetic waves are electromagnetic waves, and it is said that it is slightly different. In general, photons are studied in quantum physics. And phonons are also the elementary particles of crystal lattice. You see. I study continuous media, continuous media like a vacuum, solids. I don't study liquids, only solids.
Right.
And I study solids, and when, namely, surface acoustical waves, and their propagations coupled with the parameters of a vacuum. And a vacuum is treated as a continuous medium.
Sorry, could you repeat that last sentence? How are the solids like a vacuum? I don't understand.
Continuous medium.
Oh, okay. Interesting. So that's
continuous media.
So
all media are continuous.
Is there any other property that likens a solid to a vacuum other than continuousness?
You see that any solid is in a vacuum. A vacuum is around any body, and therefore any condensed matter like solid can be connected with a vacuum.
Do you mean that there's a vacuum between the atoms in any solid?
In general, the air is treated in the theory of acoustic waves as a vacuum. It has vacuum parameters. The air.
I had no idea.
The vacuum parameters. For example, the electrical constant and the magnetic constant. And therefore, it is matter where there is a solid in a vacuum or here on our planet.
Right.
The air and a vacuum have the same parameters.
Sure. Well, they have the same, almost the same refractive index, or isn't that correct? I mean, you know, light traveling through air and vacuum is virtually indistinguishable. I suppose, Steve, would you be able to speak on refractive indexes of air, or are you more? Are
I
you
think it's something like 1.00005.
right? And what about refractive indexes of solids then? Is it possible to have negative refractive indices? Could we have
Some
a
people
solid
talk
that is
about it. I don't know how to think about it.
right? What about invisible materials though? Is that a possibility?
You're talking about cloaking and things. I'm not an expert in that either. But
Okay.
Aleksey, I have a couple of things to notice. You showed us the issue number 2 from June. I was interested that the first 5 authors I know, including
I cannot see his screen anymore. Can you?
Yeah, I can see it. Yeah, I know a number of those authors.
yeah, and one of them was you, in fact, Christopher.
That's right.
And another was Wang, and another was P. Contreras, and another
Yeah.
was me, and etc.
It's great.
So that was interesting that I knew the first 5 people. I'm in touch with each of them. In fact, I aimed Wang, or whatever his name is, at Aleksey.
Great.
So, and if Aleksey is still there, could you tell us where Zahir Khan is?
Where he's based?
Yeah, where he's based.
I can show you that on the.
You mean the editor-in-chief of this journal?
Yes. Yes. Is he in
Zahir
Canada or
Khan, probably Khan or Khan. I never was spoken with him, and I don't know his right name, Khan or Khan, probably Khan.
I think
Yes.
it's Khan. Yeah.
Zahir
Yes.
Khan, probably.
That's interesting.
My name is Zakharenko, and his name, my second name, family name is Zakharenko. His first name is Zahir. It's
Yes.
the same. Zahir Zakharenko.
Ah.
Probably, I think so.
Yes.
And
I have, I don't know, maybe 20 different emails from him, because he signs off before it gets published and notifies
probably
me.
he is his location in both Canada and Pakistan. Probably he has, I don't know, he has a research team. He is collaborating with some teams, research teams from Pakistan, and some teams from Canada.
That makes
And
sense.
I don't know where he lives. Maybe in Canada. I don't. I never asked him where he lives.
Maybe I can ask him at some point.
I
Yeah,
know
he may be operating from somewhere else.
In
But
Canada, there are a lot of people from Pakistan. In general, in that province of Canada.
Same with China. A lot of Chinese.
Province.
yeah, province.
One moment.
There you go.
He's up a bit. There you go.
Khan,
Here,
yeah, right
Zahir
there.
Khan.
Canada, British
Yes.
Columbia.
British
Columbia.
Columbia. Yeah, British Columbia. In British Columbia, there are a lot of people from Pakistan. The citizens of this province.
Okay. Cool.
British Columbia.
Yeah.
And
It's close to Vancouver.
I know about that. But I'm not familiar personally with Zahir Khan. I'm sorry.
Not a problem. Thank you.
So going back to your research there, Aleksey, the issue of the vacuum and the air, is that because of refractive index that you can correlate them, or are there other reasons, or is that a reason to correlate them?
about a vacuum and air.
Yeah, refractive indices, like the fact that air is transparent and so is vacuum. Is that why they're so considered so similar in your work, or is there another reason?
In the theory of acoustical waves, in this modeling, researchers do not have any difference between the air parameters and the vacuum parameters for both the electrical and magnetic subsystems.
Okay.
We don't different them.
Right. It's just a priori. We accept that as a fact.
It is simply we use the vacuum parameters when we simulate propagation of the acoustical waves in solids here on Earth, when above the surface of the solid there is the air, but not a vacuum. And we use, when above the surface, we use the vacuum parameters, well-known vacuum parameters such as the electrical constant and the magnetic constant. They are very known. Steve works with the electrical constant. Is it probably you work with complex electrical constant? Isn't electrical constant that has both the imagery and real parts?
Yeah.
In my research, I don't use complex electrical constant, and it is different field. Metamaterials, for example, I use only a narrow field in which the electrical constant is real, only real.
Yeah.
And,
Steve has a hands up.
I need to see where I can write something, where I can dump some information.
Yeah, there is a whiteboard, Stephen. If you go into share screen. Oh, wait a second.
So it is you see on the right, from the right, the third bottom from the right. It is
1, 2, 3.
Show conversation. If you
yes, chat.
Something like that, because I have anything in Russian.
Oh, that's right. Use the chat there.
Show conversation, for example, it is called.
I see raise hand, but I don't see chat.
Chat.
I see show conversation.
Right next to it.
Yeah,
next to it.
This button, show conversation.
Okay. Let me see if I can do this now. There you go. There's your refractive index of air.
Oh, cool.
I cannot see.
Are you sending this in the chat?
Yeah, in meeting chat. Yes, it turns out that hide conversation or show conversation equals chat.
That's correct. I can't see it. Did you send it yet?
I cannot see either.
Oh, wait, I see. Now.
Yes.
Oh, yeah.
Great.
Okay.
Good man. So 1 point.
Typical refractive.
So the presumably vacuum would be just 1 then. Is that correct? Or...
Air is 1.003, water 1.333, crown glass.
Yeah.
Diamond has the maximum, huh? 2.4.
Actually, no, for what they show, but rutile is even higher.
Rutile?
Rutile, TiO2.
Yeah.
I don't remember what it is, but it's higher than diamond.
Rutile like titanium.
Yes, titanium dioxide.
Whoa, so is that clear glass or clear steel? I mean, essentially.
Titanium dioxide is what makes most paints white.
Oh, right. Sorry. Yeah, of course. Have you heard of that phenomenon where they're going to make clear steel? Or they've
Yes,
made it?
I've seen that. I've seen that.
That's pretty cool. Clear platinum as well, I think. So it's basically bulletproof glass. It's like actually fully bulletproof. It's pretty deadly. I mean, there's talk about building cities and stuff out of it, but which is actually, funnily enough, I think that's in the Bible as well. So one day, inevitably, that's going to happen.
So is Aleksey able to translate what's coming in?
How do you mean?
Is Aleksey able to hear us? Aleksey, are you still there?
He's still there.
I'm here.
I hear alien interplanetary communication. I can hear the acoustic waves, whatever he's saying.
Baby? Sounds like
maybe from 1,000 light years, he's saying? 1,000 light years?
It's instantaneous across the universe.
Yeah, can we communicate with it?
Hello,
alien, how are you?
You mean if we can develop, you see that it is there is the budget for conventional communication with the speed of light. You see that we now communicate with the conventional communication based on the speed of light. And you see that it is this speed is enough to communicate very good. I can see your faces in real time. I hope maybe several seconds, maybe milliseconds. There is delay, maybe seconds, maybe you know that Elon Musk is developing the space internet, you know, and he would like to have good communication at any point of our planet.
Yes.
And it is said that the speed of light will be not enough for this purpose. Maybe within several years we will find out is it right or not. Will be some delay, several seconds or not. Is it enough the speed of light for this type of communication? But between, for example, the planet Mars and the Earth, the speed of light is not enough.
Frozen.
It's not enough. It is
got frozen
there
for
is
a minute.
Huge delay from 8 to 20 minutes.
Yeah.
For example, if I say to Steve, hello, Steve will listen to my hello only in 20 minutes. He will happy. He will say hello to me. And only, yeah, I see, right. I see right away. But his hello I will hear. I will listen to only in 40 minutes if I'm on the planet Mars.
Yeah.
This is very horrible slow connection. You see, even with neighbor planet, and only one thing there is to develop this fast, instant and planetary communications. It is based on these two fast ways. But I have to say that there is one horrible thing. One of these two waves is dangerous, and the second is very nice for living organisms.
What makes it dangerous?
It can destroy any living organism very fast, very hard. If there is very intensive waves.
Don't tell the military.
In the Soviet Unions, I know such thing that in Soviet Unions, the population of 4 institutions was died. They were dealing with this new waves.
Hmm.
They were studying them, and only in several decades they understood that they were died, namely due to this type of wave.
Right.
Is it like
very
gamma?
And
Is it like gamma waves? Gamma.
this is new. You can read the papers by Zamsha that will be published probably on the following week, I hope,
Great.
in the October issue of the Canadian Journal. And you can see at the bottom of his paper warning several lines concerning this dangerous thing, and he is very experienced with to work with this new type of radiation. It is not gamma; it is new type, not gamma, but it can destroy. And you know that any medical equipment, medical tool, when you use it to, for example, for your health, some magnetic, it is limited by several minutes, for example, because if you will use these tools for more time, it can be dangerous for body, for some. It is said, it is thought that it is due to these new type waves, because they are radiated together with the electromagnetic waves, because you see that the electromagnetic waves, the electromagnetic system has two subsystems, the electrical and magnetic, but this.
Oh no. We lose him again? Yeah.
I think so.
Yeah, again,